So now we're going to continue with vectors, and we're going to take vectors written in this form where we're just given the where it goes from and where it goes to, which, by the way, from, that would be the tail. Where it goes to, that's where it ends. That's the head. We're going to take it from that form and turn it into component form. Then we're going to find the magnitude, and a little lower down here we are going to find the direction. Okay? So first, let's just take all three of these from this form and turn them into component form. So in component form, we have to subtract the x components and the y components, and it has to be head minus tail. So it's going to be the x component from the head minus the x component from the tail, and then the y component from the head minus the y component from the tail. So we always have to do this in the order of head minus tail. Okay, so our x components here, from head to tail, -5 minus 3. And then the y components from head to tail, -6 minus 4. So that gives us -8 and -10. So there is that first vector in component form. We'll move on to the next vector, head minus tail, x components 3 minus 8, y components 2 minus -6. 3 minus 8 is -5. 2 minus -6 is 8. And our last one into component form, x minus x is 8 minus 8. And tail, or the y component, head minus tail, is 2 minus 6. So that's 0, -4. Okay? So there's all three of those in component form. Next, we're going to find magnitude. And we've already done part of the work of finding magnitude. Magnitude is the length or the distance. So we're going to use the distance formula, but we've already done the subtraction portion of the distance formula. So it's the square root of -8 squared plus -10 squared. So that's the square root of 64 plus 100. Square root of 164. 164 is divisible by a square number, 4. So it's the square root of 4, and 4 times 41 makes 164. The square root of 4 is 2, so it's 2 times the square root of 41. That is the magnitude of that vector. So then we have the square root of -5 squared plus 8 squared. 25 plus 64. So it's the square root of 89. I'm not going to be able to find any square numbers that go into 89, so the square root of 89 will be our final answer for the magnitude. And then the square root of 0 squared plus -4 squared. 0 plus 16. The square root of 16 is 4. So the magnitude of this vector is 4. And last, we're going to find direction for each vector. Okay, so we're going to use that component form. For the first vector, we got a component form of -8, -10. So we're going to put that onto a coordinate plane. -8, -10 would give me a coordinate right about there. Okay, so the vector looks like that. The direction has to give me that standard angle measure. Okay, so I'm going to turn this into a right triangle, and I need to find that angle right there. Over here, I've got a -10. Here, I've got a -8. I've got opposite and adjacent, so that's tangent. And I'm looking for an angle measure, so I'm going to have to use arctangent. So arctangent, or the inverse tangent, opposite over adjacent. -10 over -8. So I've got a calculator ready now. In order to evaluate this, I need to first make sure I'm in degree mode. I'm not, I'm in radians. So I'm going to go over and highlight degrees and then clear out of here. And I'm going to type in second tangent, -10 over -8. Since they're both negative, I could just cancel those out and make it 10 over 8. I get 51.34 degrees. Now clearly, from here all the way to here is not only 51.34 degrees. That is this reference angle right here. To get the standard angle, I need to add that 180. So I'm going to add 180 degrees, and that's going to give me 231.34 degrees. That is the direction. Okay? Anytime I find an angle to be in the third quadrant, I'm going to have to add 180 degrees. The next one, the direction, I've got a component form of -5, 8. So that's going to be left 5 and up 8. So my vector is going to look about like that. And I'm going to turn that into a right triangle. So I've got 8 here, -5 here, and I need to know that reference angle. So I've got opposite and adjacent, so I'm going to do arctangent again to find the angle measure. Arctangent, opposite, over adjacent, which is y over x. So second tangent, 8 over -5. And I get -57.99 degrees. Which means that really this angle right here, the reference angle, is 57.99, which I have to take away from 180, or I can just do that in -57.99 plus 180. Anytime I'm in the second quadrant, I'm going to get a negative here, and I just need to add 180. So -57.99 plus 180 is 122.01. So the direction is 122.01 degrees. So when I'm in quadrant 2, I'm going to get a negative number, and once again, I have to add 180 degrees. The next one is over 0 and down 4. So the vector looks like that. This one I don't need to do any of this work. It's just 0 degrees, 90 degrees, 180, 270. So this one is 270 degrees. So if it's on an axis, I've got 0, 90, 180, 270. Now we need to figure out what to do when it's in quadrant 1 or quadrant 2. So if I have something like, say it goes over 5 and, or over 3 and up 5. So a vector like that goes over 3 and up 5. I would be doing arctangent opposite over adjacent, 5 over 3. So second tangent, 5 over 3, and I get 59.04 degrees. And that makes sense in this first quadrant. So here, I do nothing to it. If it's in the fourth quadrant, say maybe it goes over 10 and down 3. So I've got a negative 3 here. For opposite, adjacent is 10. So I'm going to do arc tan opposite, negative 3 over adjacent 10. So second tangent, negative 3 over 10 is negative 16.70 degrees. And if I add that to 360, I'll get 343, and that goes all the way around to here. So 343 makes sense, 343.30 degrees. So if I'm in quadrant 4, I need to add 360. I'm going to get a negative number in quadrant 2 and 4. In quadrant 4, I'm going to add 360 to get my standard angle measure.